The next question is integral 0 to 1 sin inverse 2x by 1 plus x square dx. So this kind of problems we have dealt in the inverse trigonometric function. So if I take x as tan theta, then let us see what will happen. 2 tan theta by 1 plus tan square theta. What is this? That is sin 2 theta in terms of tan theta. So let x is equals to tan theta. If x is equals to tan theta, what is theta then? Tan inverse x according to the inverse trigonometric functions. So this is equals to x equals to tan theta. So 0 to 1 sin inverse 2 x is tan theta by 1 plus tan square theta into dx. So that is equals to 0 to 1 sin inverse, this is sin 2 theta into dx. This is 0 to 1 sin inverse of sin means 2 theta dx. This is equals to 0 to 1, 2 I am separating from the process of integration. So theta is tan inverse x dx. You may ask me a question, sir, if x is substituted in terms of theta, why didn't you change the limits? Because my intention is to leave the given function in terms of the given variable of integration itself. See, it doesn't subjected to the change of the variable of integration theta. That is why I did not change the limits, because anyway the given function is in the variable integration of x, that is x. So here also in terms of x only, therefore 0 to 1 limits are not going to be changed. So now we know how to deal this problem. So directly integral tan inverse x dx, we don't have a formula. So for which the second function, if I treat it as 1, then product of two functions. So we have a formula. What is that? Integration by parts. So 2 integral 0 to 1 tan, since this is to be used for the special functions like inverse trigonometric function, integral root of a square minus x square dx, next logarithmic function. So such kind of functions are treated to be special functions, where the second function is treated to be unity, see, into 1 dx. Now this is obviously f of x and this is second function. So product of two functions, what is the formula? 2 into first function into integral of second function dx from 0 to 1 minus integral of 0 to 1 differential quotient of first function into integral of second function dx whole dx. The bracket is closed because 2 is being multiplied with a whole. So 2 into integral tan inverse x, integral 1 dx is x, since the process is over, 0 to 1, minus integral 0 to 1 d by dx of tan inverse x is 1 by square root of 1 plus 1 by 1 plus x square into integral 1 dx is x. See, integral 1 dx is x, this dx is as usual. So 2 into x tan inverse x, substitute the upper limit 1. So 1 into tan inverse 1 minus lower limit 0 into tan inverse 0 minus, so integral 0 to 1. So here 1 plus x square derivative is 2x. So 2 is needed here. So 2x by 1 plus x square into 1 by 2. May I write this? Because 1 plus x square derivative is 2x, but only x is there, for which I have adjusted with a 2. Dividing and multiplying with a 2 I did. Into dx. So 2 into tan inverse 1 is pi by 4 minus 0 into something is 0 minus 1 by 2. So 1 plus x square derivative is 2x. So f dash x by f of x, log f of x. So log 1 plus x square. So the process of integration is over. So 0 to 1 are to be written here, and this is a closed bracket. So 2 into pi by 4 minus 1 by 2. Now you apply the upper limit minus lower limit. So log 1 plus 1 square, so 2, minus upper limit is over, lower limit log 1 plus 0, 1. So 2 into pi by 4 minus 1 by 2 log 2. So log 1 value is 0. So that is equals to 2 into pi by 4. So pi by 2 minus 2 gets cancelled. So log 2. So the next question is integral 0 to 1 x tan inverse x dx. So this is the product of two functions with the product of two functions. X is algebraic function and tan inverse x is trigonometric function. Isolate. So first function, this is f of x. So this is equals to f of x. Sorry. The next question is integral 0 to 1 x tan inverse x dx. So this is the product of two functions. So this is inverse trigonometric function and this is algebraic function. So isolate. In isolate phrase, I comes first and then x. So first function into integral of second function dx. So 0 to 1 minus integral of 0 to 1 here d by dx of tan inverse x into integral of x dx whole dx. So this is equals to tan inverse x integral x dx is x square by 2. Process is over. 0 to 1 minus 0 to 1 d by dx of tan inverse x is 1 by 1 plus x square. Integral x dx is x square by 2 whole dx. This is equals to, so I will continue this for one more step without substituting the limits. So x square by 2 tan inverse x from 0 to 1 minus this 1 by 2 being a constant, I am separating from the process of integration. 0 to 1, so x square by 1 plus x square dx. See, this is the improper function, improper fraction. Degree of f of x is 2, degree of g of x is also 2. So degree of f of x greater or than or equals to degree of g of x, then it is said to be improper fraction. That improper fraction we need to make it into the proper fraction by dividing this x square numerator with the help of denominator. Instead of that, I will prefer the adjustment. So 1 I will add and 1 I will subtract. So x square by 2 tan inverse x 0 to 1 minus 1 by 2 integral 0 to 1. So this is a minus b by c, a by c, 1 plus x square gets cancelled, so 1 dx. So this 1 by 2 is being multiplied with as a whole, minus integral 0 to 1, 1 by 1 plus x square dx. So this is x square by 2 tan inverse x 0 to 1 minus 1 by 2 integral 1 dx is x. The process is over. 0 to 1 is to be written here. Minus into minus plus 1 by 2 integral 1 by 1 plus x square dx is tan inverse x from 0 to 1. Now you substitute the limits. So in the place of x, substitute upper limit. So 1 by 2 tan inverse 1 square by 2, 1 by 2 tan inverse 1 minus lower limit 0 square by 2 into tan inverse 0, so 0 totally, minus 1 by 2 in the place of x, upper limit 1 minus lower limit 0, plus 1 by 2 tan inverse x value is 1 minus tan inverse x value is 0. So that is equals to 1 by 2 tan inverse 1 value is pi by 4 minus 0 minus 1 minus 0 is 1 into 1 by 2, 1 by 2 plus half tan inverse 1 value is pi by 4. So that is equals to, this is pi by 2 4s are 8 minus 1 by 2 plus pi by 8. So that is equals to pi by 8 plus pi by 8, 2 pi by 8 minus 1 by 2. So this will be cancelled in 4 times. So pi by 4 minus 1 by 2. So the next question is 0 to pi x sin x by 1 plus cos square x dx. So let us take this to be I as usual. So we have integral 0 to a f of x dx is equals to integral 0 to a f of a minus x dx. So this is equals to integral 0 to pi minus x sin pi minus x by 1 plus cos square pi minus x dx. So 0 to pi, so pi minus x sin 180 minus x is sin x by 1 plus cos 180 minus x is cos x whole minus cos x whole square cos square x dx. So 0 to pi, so pi into sin x by 1 plus cos square x dx minus integral 0 to pi x sin x by 1 plus cos square x is I, therefore it is simply I. So this is equals to, so 2I is equals to pi into integral 0 to pi sin x by 1 plus cos square x dx. So from this, the same kind of problems that we have done earlier also, so it is the same. Therefore I have made it for you. So cos x is equals to t I have taken, minus sin x dx is dt, sin x dx is equals to minus dt. So multiplying with minus on both the sides. So I have changed the limits as well. So cos pi value is minus 1, cos 0 value is 1. So this is 2I is equals to pi. So 0 to pi values are 1 to minus 1. So sin x dx value is minus dt by 1 plus cos x is t, cos square x is t square. So pi into So this minus we want to remove. Then we have to interchange the limits. So minus 1 is upper limit and 1 is the lower limit. So here I have interchanged. So 1 is the upper limit, minus 1 is the lower limit. So it is of the form 1 by 1 plus x square dx, which is tan inverse x. So tan inverse t here. So since the process is over, minus 1 to 1 is to be written here. So tan inverse upper limit t is replaced as 1. So upper limit minus lower limit. Tan inverse t value is minus 1. So tan inverse 1 is pi by 4 minus tan inverse of minus 1 is minus pi by 4. So pi by 4 plus pi by 4, 2 pi by 4. So 2 2s are 4. So this is 2i is equals to, if this 2 transpose here, then 2 into 2, 4. So pi into pi, pi square by 4 is the answer. In this section, we derived definite integrals of integral sine power mx, integral cos power nx dx, integral sine power mx into cos power nx dx between 0 and pi by 2 for positive integers m and n. First of all, what is the necessity of reduction formulae? So we have already discussed all these things in the indefinite integration, but so let me tell you, for example, if I am asking you to evaluate what is integral sine x dx, then you can simply say that minus cos x plus c. That's okay. So if I ask you what is sine square x dx, but we cannot say this directly as that of integral sine power 1x dx. So sine square x, a little more efforts have to be put here to find the integral sine square x dx. So sine square x dx can be written as 1 minus cos 2x by 2 dx. Then this is integral 1 by 2 dx minus integral 1 by 2 integral cos 2x dx. So 1 by 2 integral 1 dx is x minus 1 by 2 integral cos 2x is my sin 2x by d by dx of 2x2. So totally 1 by 4 sin 2x plus c. Not as easier as integral sin x dx. So we compare to sin x, sin square dx, sin square x dx is a little more complicated. But if I am asking you integral sin cube x dx, then it can be done in sin square x into sin x dx. So sin square x can be written as 1 minus cos square x into sin x dx. Otherwise, this sin square x, or sin square x can be written as 1 minus cos 2x by 2 into sin x dx. So 1 by 2 integral sin x dx minus 1 by 2 integral cos 2x into sin x dx. So this is 1 by 2 integral sin x is minus cos x minus 1 by 2. So I'll multiply 2 and divide by 2. So 2 cos 2x into sin x. So as I have multiplied with the 2, I'll divide by 2 also. So minus 1 by 2 x cos x minus 1 by 4. 2 cos a sin b. So sin a plus b minus sin a minus b. So sin 2x plus x 3x minus sin 2x minus x. So x dx. So this is minus 1 by 2 cos x minus 1 by 4. Integral sin 3x is minus cos 3x by 3. So 3 4s are 12. So minus into minus plus. Integral sin x is minus cos x again. So minus cos x is plus c. This is how we will evaluate. And if I am asking you to evaluate integral sin power 4x dx, this is sin square x whole cube, otherwise sin square x whole square. Sin square x is sin square x whole square dx. Sin square x is 1 minus cos 2x by 2 whole square dx. So this is 1 plus cos square 2x minus 2 cos 2x by 2 dx, and if I am and the steps proceed. So 1 plus this cos square x can be replaced as 1 plus cos 2x by 2, and so integral sine power 5x dx. So this is sine cube x into sine square x dx. So we have the formula for sine 3x. What is sine 3x? 3 sine x minus 4 sine cube x by 3. Okay, so this is 4 sine cube x equals to 3 sine x minus sine 3x. So this is 1 by 4 into 3 sine x minus sine 3x into sine square x is 1 minus cos 2x by 2 dx. So and so on. So as the power increases, the complication also increases with the power. So sine power 6x dx onwards, actually we don't have any multiple angles formula. Therefore we have a necessity of having a formula. So that formula is called a reduction formula. And if that reduction formula, if we know, then actually whatever the power that is given to us, if we substitute n value in that, actually we will be getting, we can evaluate that integral easily. So if integral sine x dx is given, we can find integral sine 2x dx also we can find, integral sine 3x plus 4 dx also we can find. So sine associated with whatever the linear expression that is, so we can evaluate it easily. So integral sine x dx is minus cos x plus c. This is sine 2x is minus cos 2x by 2 plus c. So this is minus cos of 3x plus 4 by d by dx of 3x plus 4 is 3 plus c. Therefore, whatever the integration is followed by sine associated with the linear expression, we can evaluate it easily. But whenever it comes the powers, integral sine power 6x dx, integral sine power 10x dx, so as the power increases, actually we are unable to evaluate with the available formulae, with the available multiple angles formulae. So therefore, as the power increases, the complication also increases. Therefore, there is a necessity of a reduction formula. So let us evaluate integral 0 to pi by 2 sine power nx dx, where n is an integer greater than or equals to 2. So for n greater than or equals to 2, we are going to establish a relation called reduction formula. So first and foremost, integral 0 to pi by 2 sine power nx dx. This is not a new thing. We have discussed all these things in the indifferent integration. So with just integral sine power nx dx, here this is only applicable. So we are only confined to 0 to pi by 2 limits only. So here onwards, actually we will be deriving the formulas for integral 0 to pi by 2 sine power nx dx, integral 0 to pi by 2 cos power nx dx, integral 0 to pi by 2 sine power mx into cos power nx dx. Okay. So I'll take it as integral 0 to pi by 2. This sine power nx can be written as sine power n minus 1x into sine power sine x dx. So when nothing is there, power 1 can be written. So when bases are equal, exponents are added, n minus 1 plus 1. So we are left with sine power nx dx. So let us take this to be the first function and this to be the second function. So we have a integration by parts formula. So let us use it. So this is equals to, I'll take it as In. Okay. So therefore In is equals to integral 0 to pi. So first function f of x. Remember, integral f of x into g of x dx is equals to f of x into integral of g of x dx minus integral of d by dx of f of x into integral g of x dx whole dx. So that's what we have learnt in the indefinite integration. So that's what the same formula I'm using here. So first function into integral of second function sin x dx. So 0 to pi by 2 is to be written here, minus integral of 0 to pi by 2 d by dx of sin power n minus 1x into integral of sin x dx whole dx. So this is equals to sin power n minus 1x, integral sin x is minus cos x. So from 0 to pi by 2 minus integral 0 to pi by 2. So d by dx of sin power n minus 1x. So we know the formula for d by dx of sin x. So d by dx of sin x is cos x. So this is d by dx of sin power n minus 1x, means sin x whole power n minus 1 is this. So let us take sin x to be x power n into x power n minus 1. So n minus will come forward, n minus 1 into the x power n is d by dx of x power n is n into x power n minus 1. So this x is sin x whole power n minus 1 minus 1 n minus 2, x power n into x power n minus 1. So n minus 1 minus 1 into whichever function that I have taken it to be x for the time being, we need to differentiate it later. That's what we have learnt in the first year derivatives chapter, differentiation chapter. Into d by dx of sin x is cos x into what is integral sin x dx? Already we have used here, minus cos x. Integral sin x dx is minus cos x. So the bracket of into dx as usual. This is equals to minus sin power n minus 1x into cos x from 0 to pi by 2. From 0 to pi by 2 minus integral 0 to pi by 2. Minus into minus is plus. Since n minus 1 is a constant, we are separating it from the process of integration. Again I am telling you, minus into minus plus n minus 1 constant is taken apart. So integral 0 to pi by 2 sin power n minus 2x into cos x into cos x is cos square x dx. So that is equals to minus sin power n minus 1x into cos x from 0 to pi by 2 plus n minus 1. So 0 to pi by 2. This is sin power n minus 2x. Cos square x can be written as 1 minus sin square x dx. Minus sin power n minus 1x into cos x from 0 to pi by 2 plus n minus 1. See here, integral 0 to pi by 2 sin power n minus 2x into 1. So that is sin power n minus 2x dx. So plus into minus, minus n minus 1 into integral 0 to pi by 2 sin power n minus 2x into sin square x. So bases are equal, exponents are to be added, sin power n minus 2x plus 2. So minus 2 plus 2 gets cancelled. We are left with sine power nx dx. So this is equals to, now I am substituting the limits now. So minus, substitute the upper limit. Simply wherever you find wherever you have x, simply substitute pi by 2 as an upper limit, minus wherever you have x, substitute 0 then. Okay, so sine power n minus 1 x, n minus 1 into pi by 2. So sine pi by 2 whole power n minus 1, sine 90. So 1 power n minus 1 is 1 into cos pi by 2 is 0. This is 0 as a whole, minus lower limit now. Sine power n minus 1 into 0. So sine 0 whole power n minus 1. Sine 0 is 0. 0 into something. This is 0. So actually the whole will be 0 here, plus n minus 1. Listen, power n is there. I have taken in. If the same function 0 to pi by 2 sine power n minus 2x dx. Again I am telling you, 0 to pi by 2 sine power nx dx. If power is n, the suffix I have taken it to be in. So here power n minus 2, then I will take it as in minus 2, minus of n minus 1. See this, integral 0 to pi by 2 sine power nx dx is in. So this is equals to in. This minus of n minus 1, if you bring here, n minus 1 into in is equals to n minus 1 in minus 2. So if I take in as a common, then 1 plus n minus 1, 1 gets cancelled. This whole is nin. Therefore in is equals to n minus 1 by n into in minus 2. So on applying the successive reduction, so in minus 2 will be, so if it is n, so the numerator is decreased by 1 and the denominator is as it is. Here it is decreased by 2. So in minus 2 will be decreased by 1 in the numerator. So n minus 2 minus 1, n minus 3 by, if it is n, the same n we got. Same, if n minus 2 is what we are getting into I. If it is n, it is decreased by 2. If it is n minus 2, it is decreased by 2. N minus 2 minus 2, n minus 4. Likewise, what is in minus 4? So we can write, so n minus 5 by n minus 4 into in minus 6. So likewise, if we reduce it, if n is even, then we will end up with the I naught. If n is even, we will end up with the I naught. So what is I naught? So I naught is equals to, so if n is even, if I take I2 is, simply you substitute in this, n minus 1 by n, 2 minus 1 by 2, that is 1 by 2. Okay, I 2 minus 2 is 0. So I naught, we cannot use the, we cannot substitute this 0 in the reduction formula that we got earlier, because this is valid where n is greater than or equals to 2, is equals to 2, more than 2. So even I2 also we can use, because it is n equals to 2, therefore we can use. I0 we cannot use because here n is 0. So 0 is not greater than 2, it is less than 2. So what is to be used? Nothing. Simply substitute integral 0 to pi by 2. So what is in? Integral 0 to pi by 2 sine power nx dx. In this you substitute I naught. So what is I naught? 0 to pi by 2 sine power 0x dx. Something to the power of 0. So 1. So integral 0 to pi by 2, 1 dx, which is x. So integration is over. So 0 to pi by 2 is to be written here. So pi by 2 minus 0, which is pi by 2. Okay. So that means here I2 is 1 by 2 into what is I0 here? Pi by 2. So likewise, if n is odd, so it will be end up with I1. So before I1, let us see what is I3. I3 is substitute 3 in this. So why are we substituting? Because this 3 is greater than 2. Therefore you substitute in this. So n is 3 minus 1. So 2 by n is 3 3 minus 1 is I1. So what about I1? Can we substitute I1 in this? No, because n greater than 2. As long as n is greater than 2, then only we can substitute that value in this. Otherwise we cannot substitute. So what is to be done? Simply integral 0 to pi by 2. So what is this one? Sine power 1x dx. What is integral sine x? Minus cos x. Minus cos x from 0 to pi by 2. So this is equals to minus cos pi by 2 is 0, minus cos 0 is 1. So this is 1. So therefore, if n is even, we are ending up with pi by 2. If n is odd, so we are ending with 1. So actually these are the two examples I have taken, I2, I0. Before that, I4 we will be getting. What will be this I4? Simply this is substitute. 4 minus 1 by 4, I4 minus 2 is 2. That means 3 by 4 into I2. So if I am writing I4 here, then it is 3 by 4 into I2. So if I am writing I5 here, what is I5 here? Substitute simply. 5 minus 1 by 5. So how much it is? 4 by 5 into I. N minus 2 is 5 minus 2 I3. Therefore, I am winding up with the ultimate answer. So on applying successively, integral 0 to pi by 2 sine power nx dx is n minus 1 by n into n minus 3 by n minus 2. Reduce 2 on the numerator and reduce 2 in the denominator as well. Okay. So n minus 5 by n minus 4. If you want n minus 7 by n minus 6 etc. up to how much? So 3 by 4 into 1 by 2 into pi by 2 if n is even. We have discussed this. So if n is even, so we will be end up with I0. Okay na? So I0 before I2, I2 before I4, all we have discussed before. So I4 is, so this is the reduction formula. I4 is minus 1 by 4, I4 minus 2. So 3 by 4 I2. 3 by 4 into I2. What is I2? Again. So this is valid as long as n is greater or equals to 2. So this is I2. It will be used even for n equals to 2 also, because the condition is n greater or equals to 2. So therefore I2 is 2 minus 1 by, this time I2 means n equals to 2. So 2 minus 1 by 2. So 1 by 2, 2 minus 2, 0. So 1 by 2 I0. What is I0? N is 0. So 0 cannot be substituted in that. So instead, integral 0 to pi by 2 sine power nx dx is In. So n equals to 0 if you substitute. In is integral 0 to pi by 2 sine power nx dx. So here I0 value is 0 to pi by 2 sine power 0x dx. So something to the power of 0, 1, integral 1 dx, x, integration is over, 0 to pi by 2, so pi by 2 minus 0, so pi by 2. So with this we will end up, and if n is odd, so this the same formula we are getting n minus 1 by n minus 3 by n minus 2, n minus 5 by n minus 4, etc. So this is 3 by, so 2 by 3 into 1 before that, so it will be 4 by 5, etc. There are so many terms in this, but actually we will end up with if this is if n is odd. If n is odd, we are ending up with 1. If n is even, we end up with pi by 2. So pi by 2 is what we are getting if n is even ultimately. If n is odd, we are getting 1. So this is I1 value. I1. So I1 means I1, n equals to 1. So we cannot use in this because this formula is valid as long as n is greater or equals to 2. I1 means something less than 2. So therefore we cannot use in this. So instead we should substitute in integral 0 to pi by 2 sine power 1x dx. What is this? This is I1. So if n is odd, so the last term will be, the last will be I1. So sine power 1x dx means sin x only. Integral sin x is minus cos x from 0 to pi by 2. So minus of cos 90 minus cos 0. Cos 90 is 0, cos 0 is 1. Minus of minus, so 1. So before this is I1. Before this is I3. Before this is I5. What is I3? Since 3 is greater than 2, so we can use in this. So 3 minus 1. So n is 3 here. 3 minus 1 is 2 by 3 I. 3 minus 2 is 1. See this. 2 by 3. So I1 value is, just now we have got, so 1. So this is how we will derive the reduction formula. So if you do not understand this, then actually we will see integral 0 to pi by 2 cos power nx dx also. So let us evaluate integral 0 to pi by 2 cos power nx dx. Let us take it as in. So this is integral 0 to pi by 2 cos power n minus 1x into cos x dx. So this is equals to, first function is this, second function is this, cos power n minus 1x integral cos x dx from 0 to pi by 2 minus 0 to pi by 2 d by dx of cos power n minus 1x into integral cos x dx whole dx. So actually everyone knows this because this is f of x into integral of g of x dx from a to b minus integral a to b d by dx of f of x into integral of g of x dx whole dx. This is integration by parts which you have learned before. So this is cos power n minus 1x integral cos x dx is sin x, since the process is over 0 to pi by 2 minus integral 0 to pi by 2. So cos power n minus 1x is cos x whole power n minus 1. What is cos power n minus 1x? Cos x whole power n minus 1x. So we don't have a formula for this. So let us take x for the time being. So for our convenience, cos x I am taking it as x. Integral x power n dx is n into x power n minus 1. So integral x power n minus 1 is n minus 1 into x power. So cos x power n minus 1 minus 1. So n minus 2. So the same thing I am writing here. N minus 1 into cos power n minus 2x into, since cos x I have taken it to be x. This is x power n minus 1 I have taken. That is why it has become d by dx of x power n into x power n minus 1. Since cos x I have treated it to be x, we have to differentiate it later. What is d by dx of cos x? Minus sin x into integral cos x dx is sin x whole dx. Integral cos x dx is sin x. This dx is dx. Okay, so this is you substitute. Since the process, see here the symbol integration is not there, therefore you can substitute the limits now. So cos power, in the place of x substitute upper limit. Cos x is pi by 2. Cos pi by 2 is 0 whole power n minus 1. So 0 whole power n minus 1 is 0 into something is 0. Lower limit. Substitute this here. Cos power n minus 1 into 0. So cos 0 is 1 whole power n minus 1 is, this is 1, but sin 0 is 0. So this is as a whole, everything is 0 here. So minus into minus. So plus n minus 1 I am separating from the process of integration. Integral 0 to pi by 2. So here cos power n minus 2x into sin x into sin x is sin square x, can be written as 1 minus cos square x whole dx. Okay, so this is equals to n minus 1 integral 0 to pi by 2. See this here, cos power n minus 2x into 1. So cos power n minus 2x minus cos power n minus 2x into cos square x. When bases are equal, exponents are added. N minus 2 plus 2. So cos power nx dx. So now this is n minus 1 integral 0 to pi by 2 cos power n minus 2x dx plus into minus n minus 1 into 0 to pi by 2 sin cos power nx dx. Now this is n minus 1. See, if integral cos 0 to pi by 2 cos power nx dx is in, then integral 0 to pi by 2 cos power n minus 2x can be written as in minus 2 minus n minus 1. See, integral 0 to pi by 2 cos power nx dx has been treated it to be in before. Therefore, I am just replacing it with the in. So this is all in only. So this is equals to in plus n minus 1 in is equals to n minus 1 in minus 2. So take in as a common factor. So 1 plus n minus 1. So 1 gets cancelled is equals to n minus 1 in minus 2. Therefore, in is equals to n minus 1. It is multiplying here. It will be dividing into in minus 2. And this is valid as long as n is greater or equals to 2. So from now on applying successive reduction, we will be getting different values. So if in is equals to n minus 1 by n in minus 2, so this in minus 2, if I try to substitute in that, if it is n, the power the denominator is decreased by 1, the denominator is as it is, and here it is reduced by 2. Then n minus 2, if I try to find, then it will be n minus 2 minus 1, so n minus 3, the denominator is as it is, and I, this will be decreased by 2, in minus 4. So if I am trying to find in minus 4, then n minus 4 minus 1, so n minus 5 by the denominator is same, n minus 4, n minus 6, etc. And this process of reduction will continue. As even we will be end up with I naught. If n is odd, we will be end up with I1. So this I naught and I1 values are not going to be substituted in this reduction formula, because the thing is very crystal clear here. Here, as I naught means n equals to 0, which is not following this relation, since 0 is not greater than or equals to 2, it is less than 2. So we will use it directly in integral sine power 0x dx. As far as I1 is concerned, integral 0 to pi by 2 sine power 1x dx, because I1 is so 1 which is less than 2. So this will be valid as long as greater than 2 only. In is equals to 0 to pi by 2 cos power nx dx is equals to, how much we got now? N minus 1 by n, in minus 2. So on successive reduction we are getting n minus 1 by n, n minus 1 by n into n minus 3 by n minus 2, n minus 5 by n minus 4, etc. So 1 by 2 into pi by 2 if n is even, and the same is equals to n minus 1 by n into n minus 3 by n minus 2, nothing. So if you remember n minus 1 by n into in minus 2, that means in the power n it is decreased by 1 and the denominator is as it is, and here it will be reduced to 2. So from now, from the next term onwards, you keep on decrease the reduce 2 on the numerator as well as denominator. So until we reach to a number where it is, if further decreasing gives rise to 0, then we have to stop it, and if further reduction gives us a negative value, we have to stop it. And if we got 1 by 2, immediately the next term pi by 2 is to be written, and so n minus 5 by n minus 4 on the successive reduction. If 2 by 3 we got, with that actually we need to stop if n is odd. So how these values came? So if we keep on reducing, if n is even, we get I naught as the last term. If n is odd, we will end up with I1. So since I naught and I1, the 0, 1 are less than 2, and this is only valid for n greater or equals to 2. So we cannot substitute 0 or 1 values in this. Rather, we have to use in this. We have to substitute in this. What is I naught value? 0 to pi by 2 cos power 0x dx. So something to the power of 0 is 1. Integral 1 dx is x from 0 to pi by 2. So pi by 2 minus 0, which is pi by 2. See, if n is even, we end up with I naught. And what is this I naught value? Pi by 2. So, and if we are interested in finding the before value, that will be I2. What is I2? Since this 2, I2 means, since this is 2, so this reduction formula can also be used for n is equals to 2. Therefore, we can substitute in this. So what is this? N minus 1. N is 2. 2 minus 1, 1 by n value is 2. I 2 minus 2 naught. That means see this. So pi by 2. What is I2? See, this is 1 by 2 into I naught value is pi by 2. So 1 by 2 into pi by 2. And if n is odd, we end up with I1. What is the before value? I3. If it is I3, since n is greater than 2, because n is 3 is greater than 2, we can substitute in this 3 minus 1, 2 by 3 I, 3 minus 2 is 1. Okay, and what is I1? This is just one term before the last term. So what is I1? We can, since this is 1 is less than 2, which is not greater than 2, so we cannot use this reduction formula. We need to substitute in this integral 0 to pi by 2 cos power 1x dx. Integral 0 to pi by 2 cos power 1x dx. Cos power 1x means cos x only. Integral cos x is sin x. From 0 to pi by 2. Sin x value is pi by 2. Sin 90 is 1 minus sin 0 is 0. So 1 minus 0 is 1. So did I tell you that the last term is I1 value is 1 and I3 value is 2 by 3. Okay. So therefore we can conclude by telling that n is equals to integral 0 to pi by 2 cos power nx dx is equals to n minus 1 by n minus 3 by n minus 2, n minus 5 by n minus 4, etc. 1 by 2 into pi by 2 if n is even. The same n minus 1 by n into n minus 3 by n minus 2 into n minus 5 by n minus 4, etc. 2 by 3 into 1 if n is odd.